Hi, and welcome to this section of the Probability and Statistics Tutor. And in this section, we're going to continue what we started in the last section when we started talking about data sets. And we're going to continue in this section talking about the standard deviation and the variance of data sets. So let's just recall what we were talking about before. Okay, we have a collection of data. We call it a data set. Okay. And in the last section, we spent quite a bit of time talking about the mean, the median, the mode. And I told you that the mean value, the average value, is really one of the most commonly used parameters to describe a set of data. Knowing what that average value is very important because it gives you an idea of roughly what the data set is doing, the average sort of middle-of-the-road value. Okay? It turns out that there's actually another parameter that's equally important to the mean that most of you probably haven't heard about unless in taking a class in statistics, which is what you're doing now. And that's called the standard deviation. It is absolutely just as important as the mean to understand what a set of data is doing, and you'll see that in a second, okay? The first thing we'll start out to prove that to you is to tell you and to show you that if you have a class, like let's talk about grades because everybody understands grades. You have a class A and class B, or class number 1 and class number 2. Both classes have the same average grade. Let's say the average is 50. Pretty bad average, okay? But let's say both classes have an average of 50. It turns out that even though the average in both classes is 50, the actual grades themselves can be quite different from class to class, but yet they would still give you the same average of 50. And what we're going to do is we're going to explore how those grades look different from class to class, and it turns out the standard deviation is going to be very important to understand that. So let's go ahead and do that. Let's say class number 1 consists of the following grades: 20, 31, 50, 69, and 80. Okay? Now let's just calculate the mean value. Let's see what this is, okay? The mean value is going to be the sum of the values divided by the number of samples we have. So it's going to be 20 plus 31 plus 50 plus 69 plus 80, all divided by 1, 2, 3, 4, 5. Okay, so we did this before. So the average value for class 1, the numerator is going to be equal to 250 divided by 5 equals 50. So the average grade in this class was 50, and it kind of makes sense. Some grades are pretty low, some grades are okay, and then there's one guy in the 50 in the middle. So the average value is 50. So remember that because it's going to be important. Okay? Now, let's go off and look at class number 2. The grades in class number 2 are 39, 44, 50, 56, and 61. Let's calculate the average of these grades. The average value is the sum of the values over the number of values that we have. So it's going to be 39 plus 44 plus 50 plus 56 plus 61, all divided by 1, 2, 3, 4, 5. 5 grades. So what happens if you add all of these up? If you put those in and calculate the answer, you'll get 250 on the top divided by 5, which we already know from last time is equal to 50. So what have we done here, and why have I taken the time to show you this? What I'm trying to say here is these two classes, Class A and Class B, have exactly the same average, but these grades are totally different, okay? These grades, somebody had a pretty high grade, had an 80. Nobody has anything that high down here, okay? And yet there were some grades here that were really low, like 20 and 31, and yet no one has a grade anywhere close to that low. But yet, how can they have the same average? How can they have the same average? Because what you really have to visualize when you're looking at the average value is you have points, you have grades, okay? And what you're doing is, if these are your grades here, you're kind of looking for that middle of the road grade here that represents the collection, okay? So visualize this with me. What if my grades were very tightly constrained to be here? Let's say this is 50, and I had some grades lower than 50, and some grades higher than 50, or I guess lower and higher. You're looking at the camera that way. Lower than 50, higher than 50. But the grades themselves are pretty tightly packed. Well, I can have an average value of 50 because 50 roughly lies in the middle of these grades. Now, let's look at a different class. Let's say the grades vary a whole lot more, okay? Here's 50 in the middle here. Some grades are higher than 50, and some grades are lower than 50. But the spread is a lot bigger in the second class, let's say, or in the other class, okay? I can still have an average value of 50 that roughly represents the middle, even though my grades are so much farther apart in the other class. I'm just proving to you by example that you can have the same average value, but yet the spread, so to speak, for lack of a better word, how far apart the grades are around the mean can be higher or lower, but yet yield the same average value. So how do we represent that spread? Because I told you the average value is very important to understand what data set is doing. Obviously, it's very important to know what that average value is, but it's equally important, I think you would agree, to understand how far this data is spread around. Is the data very tightly centered around the mean? I mean, if the average is 50, do all of the kids have 51, 52, and 48, 49 for their grades? Are they very tightly constrained around the mean, or do they have some outliers down up here around 100 and down near 0, and the average is still in the same place? What parameter can we use to describe how spread this data actually is? That parameter is called the standard deviation. Okay, that's what it's called. The standard. Listen to the word standard deviation. What it really means is standard deviation around the mean. That's what it means. It's telling you the deviation from the mean on average. That's what it's saying. It's telling you the data is centered around the mean, but it deviates from the mean by some number, and we'll learn how to calculate it. And that number gives you a relative indicator of how spread apart that data is around the mean. That's exactly what it is. That's called the standard deviation. Okay? So what we're going to say here is in this example here, I'm going to guess here and just tell you and show you that the standard deviation, I'm going to call it SD for right now, for class 1 is greater than the standard deviation of class 2. And I haven't proven anything to you yet, but I'm just submitting that to you because these grades up here, they're centered around 50, but I have much lower grades and much higher grades. So this distribution is kind of spread out much more than this one. This one is more tightly centered around the number 50. I don't have anything up in the 80s, and I don't have anything down around the 20s. This distribution of grades is more tightly packed. So this has a smaller standard deviation than class 1, which has a larger deviation. So that's what that means, okay? So how do you calculate the standard deviation, all right? The standard deviation, some books just represent it